So this is a spring scale, and from it you can get the force that an object exerts on it. To use this, you will hang the little hanger on here, and then you have various masses, so you'll place those on there, and you can read the force that it applies. Now you want to get right down on the level with it, so this is applying a force of 1 Newton. I put another mass on there, and now we have a force of 1.2 newtons. If your spring scale stretches so much that it goes past the scale, then you can change to a different size spring scale. And also, if it touches the ground or touches the desk, you may need to hang it off the desk, like I've done this one. If that's the case, make sure that there are books to support your spring scale so that the weight doesn't make it all tip over. You'll need to use the triple beam balance to make sure you know the mass of everything, including your holder. And so you can put whatever masses you're going to put on there. They do say their mass on them, but you want to just verify. You can put those masses on there, and then you'll move the big one until it drops, and then go back one. Then move the medium one until it drops, and then go back one. And then move the little one until it balances out. Once it's balanced, you can read, so 100 plus 20 plus 0 is 120 grams. Now that'll need to be in kilograms, so you'll need to then convert to kilograms from grams. So in this lab, you're going to be looking at mass, weight, and force of gravity to see if you can determine the relationship between those things. So for your procedures, I showed you about the spring scale and the triple beam balance. So you're going to put different masses on the spring scale and record the force exerted by those masses on the spring scale. You need at least 10 different mass combinations and what the force is for those masses. I'd make a data table for mass and force. You really want your mass in kilograms, so you can either originally record them in kilograms, or you can come over here and make a second mass column and then change it into kilograms later. If you're going from grams to kilograms, grams is a base unit, so you hop 1, 2, 3 times to the left. Once you have your 10 mass and force combinations, then create a graph. Mass is your independent variable, force is your dependent variable. You'll plot your 10 data points, and then you will draw a best fit line through them that does its best to kind of get through the middle of them all. Once you have drawn your best fit line, you'll pick 2 data points that are actually on the line, may not be the points that you plotted on your graph, and you will determine the slope of that line. And then y is equal to mx plus b. You'll plug in your slope here for m, figure out what your y is, figure out what your x is, and put those letters in there. Each person should have their own data and do their own graph, but I would like for each group to also report their findings, their graph, and the slope of their line and their line equation on one of the big boards so we can share that out.